Hi, this is a short video on modeling op amps. One of the subscribers, Joaquin Curie from Argentina, sent me an email regarding how to find the gain, open loop gain, and phase, unity gain, and so forth. And I thought that would be something useful for people that are taking integrated circuit design, how to test your circuits. And I'm not going to design an op amp, but what I'm going to use the UA741 and as an example. And right here it's a B, meaning that it's a behavioral model. Okay. Now, when you're trying to test or measure the open loop gain, you got to remember that typically these have very high gain. So if you have a little bit of a voltage mismatch, that translates into a big voltage, and typically your output is going to rail to the positive or negative rail. Okay, so that's one of the things that you have to realize, that because of the high gain, it's a little bit more difficult to model, but can model it. Anyway, so one of the first things that you want to do is you want to make sure that your output is zero. Okay, and it's not going to be zero unless you put a voltage at the input that will offset the internal offset voltage, or the voltage offset voltage that's internally. So in this case, what you want to do is you want to be sure that you connect your op amp to their proper rails. In this case, I'm putting 12 volts and negative 12, and I'm grounding the inverting input, and here on the non-inverting input I'm putting a voltage source. Okay, so let's do a DC analysis. Let's, for example, set this to 0. Okay, so if we set it to 0 and do a DC analysis, and let me take this off. Okay, and if we run it, we go to view and we put the voltage, and if you notice, the output went to negative 12. Okay, and that's because there's a input voltage offset that is multiplied by the gain, or the open loop gain. Okay, so what we have to do is we have to adjust this to eliminate that input offset voltage. Okay, how do you do that? Okay, well, it's very simple. What you do is you do a DC sweep. Okay, DC sweep, and what I'm going to do is I'm going to vary this voltage. This voltage is V1, and I'm going to vary it from negative 10 millivolts to positive 10 millivolts with steps of 1 microvolt. Okay, so I have that. And in TopSpice, to plot something, in this case I want to plot out, I put the pound autoplot DC V parentheses out close parentheses, and that's going to plot this. Okay, so we'll go ahead and run it. Excuse me. And this is the plot that you see. So this should be the voltage input, excuse me, V1, and this is the output. So as you can see, there's an offset voltage, and that's actually the offset voltage that you're seeing. So what we can do is we can go ahead and expand on that. Okay, and we want to see what is the input voltage of V1, where it gives you where the output will be 0. So in this case, V out is 0, and the input voltage that you would need would be 1 millivolt. It says 1000 microvolts, so it'd be a millivolt. So what we can do now is right here where it says DC, we put 1 millivolt. Okay. So now we're going to go ahead and run it again. But we're not doing the DC sweep. What we're actually going to look is we're going to look at the voltage. And if you notice, now the voltage is 0. Okay. In other words, this millivolt that I inserted here ensures that this is at 0. And the thinking is that once you have these two balanced, all the transistors that are inside your op amp should be in the saturation mode. And typically that's kind of the rule of thumb, that if this is 0, then you assume that all your transistors in the op amp are in saturation mode and they're at their maximum gain. Okay. So now that we've done that, we've biased this correctly. So now we're ready to do a AC gain or an AC sweep. So in this case, we want to plot the output, okay, and it'll be the pound auto plot AC. And this is where it's a little bit different, since we want to plot a dB gain. We put VDB parentheses out, okay. And let's go ahead and plot phase, and I think it's VP. Okay, and I'll plot this on let's plot it in the same plot, see if they come out. We'll put a 1, meaning that it's on the same plot. Okay, so now we're going to do an AC analysis. We'll go to AC, and let's start with this. Let's start at 1 hertz. I'm sorry, not 1 hertz. This is 1,000 points per decade. Let's start at 1 hertz, and which is the start frequency, and we're going to stop at 100 megahertz. Okay. So we go ahead, hit run. Let's run the DC sweep. Okay. And there you go. Here's the gain. Okay. And this is the phase. Okay. So now from here you can tell what the open loop gain is, and the open loop gain is right here. And this is 105 dB. 105 dB. Okay. And the unity gain, the gain where it drops to 1, okay, is approximately 1 meg. So that's fairly typical of your UA741. Okay. And then of course this is your phase. Your phase is wherever you have the gain drop to 0, then it would be the 180 minus with the 108. That will give you the phase margin. Okay. Now if you notice, this is a pole, and there's another bend over here, or deflection. That's another pole. Now to see this a little bit more, or see at a lower frequency, what we can do is we can go ahead and lower that a little bit. Let's see. Let's turn these off, and let's put 0.01 hertz. That way it'll allow us to see it a little bit better. There you go. And you can see that here's a pole. Okay. So you can take the 3 dB. Okay, the 3 dB would be approximately right there. And that looks like it has a 3 hertz uh, uh, pole. Okay, and basically that's it. As long as you can do this little technique where you run a DC sweep, figure out what the offset voltage that you need to insert it, and then run the AC sweep, then you're able to see what your the characteristics of your op amp is. Hopefully this will help other